Okay, so good afternoon, Algebra 2 Trick Honor students. So today I would like to talk about the hyperbola and also parabola. So for hyperbola, so we do have two different type of hyperbola. So one is horizontal, the other one is vertical. So for the equation, it's quite similar to the equation of ellipse. And also the equation of a circle is always starting with that either x minus h quantity square or y minus k quantity square. So for the horizontal one, you started off with x minus h quantity square over a square minus the quantity of y minus k square over b square. So that equals 1. And as you may notice, for the ellipse, the sign right in between this two group here, it's considered plus. But here's a minus. And then for the vertical one, so you started off with y minus k quantity square over a square minus the quantity of x minus h square over b square. So that equals 1. So they're quite similar. Okay, so again, h comma k, it's always the center. In this one here, there's no major axis, minor axis, but we do have two diagonals. So the main diagonal, the minor diagonal. So the opposite diagonal. Okay, so the way to find out the diagonal, it's the way to set up the vertices. So for the horizontal hyperbola, the way to find out the vertices, it's always consider h plus a, comma k, and h minus a, comma k. As you can see that the vertices for those parabolas. Okay, so once you set up the vertice here, and also for this points, those symmetrical points, so the way we can find it out is by using h comma k plus b and h comma k minus b. So once you connect the box here, so once you set up the imaginary box, you'll see that it's the first asymptote is from the corner to another corner. So once you connect them, so that would be the slant asymptote. And then here's another one, the way to connect it. It's always from corner to corner. Well, there's a way to find out the slant asymptote. It's by using the formula. So that's the one I'm going to show you next. So the way to find out the slant asymptote for the horizontal one, it's y equals k plus minus b over a times the quantity of x minus h. And then for the other one, it's quite similar. For the vertical, it's also k plus minus, but instead of being b over a, it's a over b, x minus h. Well, the reason why that is because we flip the position of a and b. For the horizontal one, we started with a underneath that x here. And then for the vertical one, we started with a underneath that y right here. So again, this one, h comma k, is still considered the center. But the way to find out the vertice for this one is consider h comma k plus a. And then the other one is h comma k minus a. And also you can refer back to the formula sheet. So this one basically tells you how to find the vertices. The way to find out the foci, so let's talk about the foci. So the way to find the value of c. So that one is exactly the same formula as the Pythagorean theorem. C squared equals a squared plus b squared. So for the value of c, for the horizontal one, then that would be considered h plus c, comma k. And then the other side right here, symmetrical, h minus c, comma k. Okay, going back to the formula sheet. Okay, so the way to find out the foci, the horizontal one, h plus minus c, comma k. And then for the vertical one, similar. So h comma k plus c. And then the other one down here, h comma k minus c. Okay, so the way to find the value of c is just basically taking the square root of the quantity of a squared plus b squared. Okay, so now this one is just like a general structure. So now let's talk about the problem, the example. Okay, so going back to the packet. So number 8, identify the vertices, foci, and then asymptotes of each, then sketch the graph. Okay, so let's do that. So this one, okay, let me, if I can highlight it. Okay, so copy and paste again. Okay, so what we got here is negative 16x squared plus y squared, and then minus 64x minus 2y minus 79 equals 0. So we need to follow those traditional steps. The way to regroup, the way to complete the square, and the way to factor so we can come up with the equation of the hyperbola. Okay, so step 1. So once again, isolate the constant term. And then regroup. So it looks like this one we need to start it with y first, y squared first. Well, because that always you start with the positive term, the positive highest, the quadratic term. So y squared. So things that goes along with y squared, we do have negative 2y. And then the next one we do have plus negative 16x squared. And then minus 64x. Okay, just leave that in blank. And then the constant, negative 79. So just want to take that to the right hand side. So we do have positive 79. Now before you complete the square for this, make sure that any greatest common factor we can pull out. The greatest common factor in terms of the coefficient. So y squared minus 2y. So this one, just rewrite it. And then take out negative 16. So we do have x squared plus 4x. And then blank. So that equals 79. And then step 2. So complete the square, b over 2, quantity square. So for this one, we can use what? Negative 2 for b. So negative 2 over 2, quantity squared, then that's 1. And then this one here, 4 over 2, quantity squared, then that'd be what? 4. So f1 here. Okay, I'll just put it into the next for step 2 here. Rewrite it. So once we figure out the number, we just add those numbers. But make sure that you need to add the same quantity on both sides. So y squared minus 2y plus 1. So that just take care of the first group, the y group. And then for the x group, similar. So f4 here. Now, got to be careful with the number that you're adding on both sides. Check the coefficient here. The leading coefficients, it's 1. So 1 times 1, then that'd be 1. So we're adding 1 for the first group, the y group. And what about for the second group? So it looks like we're adding 4 here, but actually we're adding negative 64. The product of negative 16 and 4, so negative 64. Okay, so negative 64 on the right hand side. And then step 3. Now we can factor it. So this one turns out to be y minus 1 quantity square minus 16 times the second group, x plus 2 quantity square. So 79 minus 64, then that would be considered 15 plus 1, then that would be 16. And then step 4, divide by the constant, the new constant on both sides. Divided by 16. So eventually we can end up with y minus 1 quantity square over 16 minus x plus 2 quantity square over 1. So that equals 1. And what kind of hyperbola is this? Well, you started with y first, so it's a vertical hyperbola. Okay, so let me just bring it back to the packet here. So we got y minus 1 quantity square over 16 minus x plus 2 quantity square over 1, then that equals 1. So identifying the center, so the center is h comma k, which is what? Negative 2 comma 1. So negative 2 comma 1. Got to be careful the way that you identify the value of h and k. The value of h and k, the value of h is always right next to x. And then k, it's always right next to the dependent variable y. So negative 2 comma 1. And now what else do we need to find out? The vertices. If that's a horizontal hyperbola, well, this one's the vertical hyperbola, so the way to identify the vertice, it's h comma k plus a, and also h comma k minus a. So we do have negative 2. Well, a squared here, it's considered 16, so a is 4. And then b squared is 1, so that means b is 1. So k plus a, so that means it's considered 1 plus 4, which is 5. And then negative 2 comma k minus a. So k is 1, so 1 minus 4, then that'll be negative 3. So negative 2 comma 5 right up here. And then negative 2 comma negative 3 all the way down here. Again, it's symmetrical. And then to find out the other 2 points for the imaginary box here, so let's figure out the other points. So we do have h plus b comma k, and then h minus b comma k. So h is negative 2, so b is 1, so negative 2 plus 1, then that'll be negative 1 comma 1. And then the other one is negative 2 minus 1, so negative 3 comma 1. Okay, so plot the point, check that on the graph, making sure that they're balanced, symmetrical. So negative 1 comma 1. And then the other one is negative 3 comma 1. And then you want to draw the box to connect those dots here. So since we do know that this one it's a vertical hyperbola, so that means we need to connect those corners for the imaginary box. So we can get the asymptote. Extend it all the way through. This one too, extend it. And then after that, from the vertex, you can make the parabola. So one is facing upward. And then the other one is facing downward. Again, the horizontal, well, not the horizontal, the slant asymptote. So basically that shows the boundary of the parabola. So this one I need to stretch that a little bit wider because that it follows along with the slant asymptote. Okay, so now let's see what else that we need to figure out. The foci, the way to find the foci. So let's find the value of c. So c is always square root of a squared plus b squared, just like the Pythagorean theorem. So what we got for the value of a, which is 4. Well, just a squared plus b squared. So 16 plus 1, then that's 17. So it's root 17. So root 17, what is that about without using the calculator? So root 17. Well, this one is greater than root 16, but it's less than root 25. So this one is less, well, it's less than 5, but it's greater than 4. So educated guess, I would say that's about 4.5, 4.6 something, or perhaps 4.5, 4.45 maybe. Okay, so count it, about 4.5 unit up from the center. So 2 plus 4.5, then that'll be 6.5, somewhere right here. And then the other one is down here. So for the foci, so we do have h comma k plus c. So negative 2 comma 1 plus root 17. And then the other one is negative 2 comma 1 minus root 17. Excuse me, for the foci. Again, the center is right here, which is what? Negative 2 comma 1. Okay, so for the hyperbola. Okay, so now let's try another one, number 10. Quite similar. Again, let me just copy and paste this one. Okay, just... Okay, so copy and paste right here. Brand new slide. Okay, so here's what we have. Number 10, so 4x square minus 25y square. Whoops. So that equals 100y plus 200. So before you complete the square, you want to regroup them. Constant, you want to isolate the constant. So it's 4x squared minus, well, let's just put in this, plus negative 25y squared minus 100y. So that equals 200. And it looks like the 4x squared group, this one no need to complete the square because that's only by x squared, 4x squared itself. So for this one, we want to take out negative 25. So we do have y squared minus plus 4y, and then plus blank. So that equals 200 plus blank. Complete the square. So b over 2 quantity square. So then that'd be 4 over 2 quantity square, which is 4. So F4 right here. So that means the other side, we need to add negative 100. Because that negative 25 times 4, that's a negative 100. So it's 4x squared minus 25 times y plus 2 quantity squared. So 200 minus 100, then that's 100. And then divided by 100 on both sides. So this one is just dividing by the least common denominator, 4, 25, and 100. So the LCD. So divide it. So we do have x squared over 25 minus y plus 2 quantity squared over 4. And that equals 1. So the center here, so that will be considered 0, comma, negative 2. And then the value of a squared is 25, b squared is 4. Okay, so let me just rewrite it back to that page. Okay, so this one, x squared over 25 minus, so what is it, y plus 2 over y plus 2 quantity square over 4. Y plus 2 quantity square over 4 equals 1. Again, the center, so 0, comma, negative 2. So 0, comma, negative 2. And we do know that this one is a horizontal hyperbola. Well, the reason why that is because x squared goes first. So we do know that a squared is 25, so that means a is 5. So this one counted 5 units to the right, and then 5 units to the left to get those vertices. And then to get those symmetrical points, so this one would be considered 2 unit down, 2 unit up, because b squared is 4, so that means b is 2. So 2 unit up, and then 2 unit down. And then we can set up the imaginary box here. Okay, let me just put in the dotted line again. So it looks like I need to recalibrate the pen. Again, the corner, once you connect those corner, the opposite corner, and then you get the slant asymptote. If you want to find out the slant asymptote exactly, just follow through the formula. So let me just sketch the graph first, and I'll show you. Okay, we do know that it's a horizontal hyperbola, so it goes this way. And then the other one is going this way. So just like two symmetrical parabola, one is going to the left, the other one is going to the right. Yeah, this one should be symmetrical. Looks like this one's a little bit wider, the other one is skinnier. Okay, let me just fix this. Okay, so now let's see what else. Well, the next thing that we want to find out is the foci. Okay, let's find out the foci. The way to find the foci is just find the value of c. So c is what? Square root of a squared plus b squared. So 25 plus 4, 29. So square root of 29. So again, in order to find out what square root of 29 is, you can always approximate it. So this one is less than, well, it's greater than 25, square root of 25, but it's less than square root of 36. So it's around between 5 and 6. It's about what, 5.4 something? So somewhere over here. And then the other one is somewhere over here. And then for the foci, so this one will be considered h plus c. So root 29, comma negative 2. And then the other one is negative root 29, comma negative 2. Okay. Now, for those you might be wondering, how do I get a slant asymptote for this? So according to the structure, slant asymptote is always considered y equals k plus minus. This one's a horizontal hyperbola. So the way to find out the horizontal asymptote is like a over b, quantity of times the quantity of x minus h. So just want to make sure that from the formula. But that one's for the vertical. The horizontal one is k plus minus b over a times the quantity of x minus h. Okay, so this one is the horizontal. So this one, the slope, is supposed to be b over a plus minus b over a. Well, the reason why it's plus minus because that's going to two different directions, from left to right, and then the other one's from right to left. Okay, so y equals k, which is negative 2, plus minus b over a, so 2 over 5, and then x minus h, 0. So try to simplify it a little bit. Then this one is considered y equals negative 2 plus minus 2/5 x. Well, let's find out the slant asymptote. So negative 2, so 2 unit down, and then 5 unit to the right and 2 unit up. Or it could be 5 unit down, 2 unit down, 5 unit to the left. That's right. And then the other slant asymptote here, 2 unit to the top, and then 5 unit to the left, 2 unit down, 5 unit to the right. So plus minus for the slope. Okay, so now the next one I would like to talk about would be the parabola. We actually talked about the parabola before. The original one, the up and down parabola or the sideways parabola, the one facing to the left or to the right. But now this time the parabola is going to be written in terms of the conic structure. So we do have two different types of parabola. One is considered horizontal, and the other one is vertical. So for the horizontal one, it's always written as x minus h. So that equals 4p times y minus k quantity squared. So just want to make sure that the formula, there's so many formula structure that I need to recognize for this section here. Okay, so for the parabola, horizontal, the other way around actually. It says y minus k quantity squared equals 4p. So that equals 4p times x minus h. Now what happens if I want to put it in this way? X minus h equals, well, the only thing I can change here is can I convert this one to 1 over 4p? Or y minus k quantity squared equals 4p times x minus h. Well, for those who might be wondering why this one can be written like two-way, well, because this one is considered multiplication. Think about that. If you just take this one over to the other side, it's considered what? It's considered like division. Okay, so division, multiplication. So just like cross multiplying, so it's the same thing. So x minus h times 4p, so that equals what? Y minus k quantity squared. And then for the vertical, also can be written like this. So y minus k equals 1 over 4p, and then x minus h quantity squared. Or it can be written as x minus h quantity squared, so that equals 4p times y minus k. It's the same thing. Again, so for the vertex here, well, there's no center, so the vertex for both of them, it's always considered h comma k. And then the way to find the foci, so in order to find out the foci for the horizontal parabola, then that will be considered h plus p comma k. And then for the vertical one, then that would be considered h comma k plus p. Okay, so to look at that, the formula packet here, or the formula sheet. Okay, so for the focus, horizontal one, it's h plus p comma k. And then the vertical one, h comma k plus p. And then directrix. So got to be very careful with the way to find the directrix. So if that's a horizontal, it looks like this. And then the vertical, then that'll be like this. So h comma k, it's always the vertex. And then the focus, which is right here, h plus p comma k. And then this one right here, h comma k plus p. Directrix, then that'll be considered, well, for this one is x equals h minus p. So directrix would be this one right here. So for those of you who might be wondering what a directrix is, well, this one is kind of like showing the boundary of the parabola, or showing that the balancing line of the parabola. And this one too, so y, then this one would be considered y equals k minus p. Directrix. Okay, so now let's see. Example that we have for this one. Okay, so number 12, number 14. We'll take a look at that. Okay, so once again, copy and paste. Sometimes it's kind of difficult to copy and paste for this from the PDF file. Okay, here we go. And for those who might be wondering, do I need to complete the square for this? Well, you'll see that in a minute. Okay, so here's what we have. So x squared plus 6x plus 2y plus 9. So follow through the exact same kind of strategy. So we want to group the like term. So this one here, we want to take out, well, let's just put in that x squared plus 6x together. And then the rest of those terms, just take that to the right hand side. So we do have negative 2y minus 9. And it looks like we're going to be dealing with a fraction here. Okay? So you try to complete the square for this one. So we do have x squared plus 6x. Well, let's see. Yep. Plus 9. Because that's 6 over 2 quantity square. So then that'll be what? 9. So add 9 on the left hand side and then add 9 on the right hand side. So we do have x plus 3 quantity square equals negative 2y. So now this one compared to the original form, so we do have x minus h quantity square, so that equals 4p times y minus k. So definitely this one is a vertical parabola because that's x squared. So identifying the value of h comma k, so we do have negative 3 comma 0. Well, this one can be written as x plus 3 quantity square, so that equals negative 2 times y minus 0. And then for the focus, so focus we do have, well, let's find the value of p here. So the value of p, then that'll be, well, 4p equals negative 2. So that means p equals negative 2 over 4, negative 1/2. So for the focus, then that'll be considered negative 3. Well, it's a vertical parabola, so the focus would be negative 3 comma negative 1/2. It's actually facing downward. And then directrix, then this one will be considered y equals k plus p. No, k minus p. Then that'll be negative 0 minus negative 1/2. And that'll be positive 1/2. Okay, so now sketch the graph. So negative 3 comma 0. Which is the vertex. And then focus negative 3 comma negative 1/2. So negative 3, negative 1/2. Down here. So the parabola is facing down this way. And now let's see what else that we have. The directrix. Directrix is y equals 1/2. Okay, so y equals 1/2. Which is this line right here. And now for those you might be wondering, well, this one's the vertex. That means we do have a line of symmetry here. Yes, we do. Okay, so we can always make the line of symmetry going through this vertex and the focus. Another thing we need to find out is the x-intercept, the y-intercept. Well, the x-intercept is the same as the vertex. So the way to find out the y-intercept, so we want to set x equals 0. So this one turns out to be 0, 0. So we left with 2y plus 9 equals 0. So 2y equals negative 9. So that means y equals negative 9 over 2. Or y equals negative 4.5. So negative 4.5, which is right here. We do know that it's symmetrical, so that means the other point is supposed to be 3 units to the left. And negative 6. And then simply connect the vertex along with the point that we just found. So that would be the parabola. So make sure that you need to complete the square, convert that to the structure, the vertex form for the parabola with the value of p, the p form. And then 14 is quite similar, so this one is x squared plus 4x plus y equals 0. Okay, so 14. So we got x squared plus 4x plus y. Equals 0. Okay, making sure that copy the right thing here. Okay, so regroup. Well, this one is 4x, not 4y. Excuse me. And then for the y, we just want to take that to the right hand side. So complete the square. So we do have x squared plus 4x plus 4. Add 4 on both sides. And then you want to factor it. So x plus 2 quantity square. So that equals negative 1. Take out the greatest common factor. So y minus 4. So again, this one is going to be the vertical parabola. So h comma k. So we do have negative 2 comma 4. And then for p equals negative 1. So solve for p. So we do have p equals negative 1 over 4. It's a fraction again. So we do know that it's a vertical parabola. So that means for the focus, so it's h comma k plus p, which is what? Negative 2 comma 4 plus negative 1/4. So 3 and 3/4. And then directrix, then that'll be considered y equals k minus p. So k, so 4 minus negative 1/4, so which is 4 and 1/4. Okay, so going back to the template. So for the vertex, we do have negative 2 comma 4. And then the focus, negative 2, 3 and 3/4. Wait a minute. No, negative 2, 3 and 3/4. Okay, because that's facing downward, so negative 3 and positive 3 and 3/4. And let's see what else. Directrix, y goes 4 and 1/4. Okay, so it's right here. Should be a little bit lower. And then another thing that you want to do, you want to find out the y-intercept. So set x equals 0. So we got y equals 0. So 0, 0. 2 unit to the left, 2 unit to the right, and then the line of symmetry. Simply just connect the vertex with those points. So this one is just an upside down parabola. Okay. And let's see what else that we need to find out for this one here. Vertex, focus, axis of symmetry, directrix, min, max value. Yeah, intercepts. So again, if that's an upside down parabola, we can find the max. So the max, the one for the previous one, which is the what? The vertex. And then this one, the y value for the vertex right here. And that'll be considered what? Y equals 4. And then for the previous one, the max would be what? 0. Just the y value. Alright, so that's it. So thank you for watching it, and I'll see you next time. Bye, guys.